We're going to talk a little bit about error. There's two types of values that we're going to have when we're calculating error. We're going to have the accepted value. This is a quantity used by general agreement in the scientific community. Sometimes it comes from a resource. Sometimes it also comes from a calculation. So there's a lot of things that could be considered the accepted or the theoretical value. The other option for us is the experimental value. So this is a value that someone was in the lab and measured. So this is a little bit different than the accepted in that it was measured by someone and there's no really indicator of how correct they were. So what error is it's the difference between the accepted value and the experimental value. So error by itself is equal to experimental minus accepted or accepted minus experimental. So you're looking at the error. The thing that we're going to be using is called the percent error. So on top we have the absolute value, because when we calculate the error we just want to know how far away from the true value we are, not necessarily in what direction. And then we're dividing by the accepted. So that's the really important part. We have to divide by the accepted value in order for our values to be considered appropriate. And then we're going to times by 100. The 100 we don't count for sig figs because it's just moving the number from decimal form to percentage form. So it's just like a grade. If you get a 10 out of 15, you divide it and then multiply 100 to get it into percentage form. So we don't count that. The sig figs for this type of problem are a bit tricky because we have mixed operations. We have subtraction and division, which both have different rules, making it a bit tricky. So this is one type of example. We're going to take a look at a couple other types of examples later. But in this example, we have a student measuring a volume of a gas to be 45.26 milliliters. They then calculated the volume was to be 48.90 milliliters. What is the percent error? The 45 is the experimental value because this problem specifically says, and in an experiment, a student measured the volume. So someone physically measured the volume to be that in an experiment in a lab. The other value, it was determined as what the volume should have been through a calculation. Sometimes that happens, depending upon the type of problem and the situation that you have with it. So we're going to take the absolute value of the experimental minus the accepted all over the accepted value. So the important part is that the accepted value is on the bottom. If you switch the numbers on the top, you subtract one from the other by accident, it won't make a difference because you have that absolute value. So because we have the sig figs with this, we have to make this problem, we have to kind of split it up. So we're going to take 45.26 minus 48.90. Now this is a subtraction problem, so we have to take a look at the location of our significant figures. So our location of our significant figures in this problem, they're both significant in the hundredths place. So when we do this subtraction, we're going to round to the hundredths. So you end up with negative 3.64. So notice we have 3 sig figs there. We want the absolute value of it. So we're just going to take the 3.64, divide it by 48.90 times 100 to determine our sig figs. So we have 3 sig figs on the top of the fraction, 4 on the bottom. So my answer should have 3 sig figs. So multiplication and division, we go by the count. So we end up with 3 sig figs in our final answer. You end up with 7.44%. Make sure you write that percentage sign. It's kind of like your unit in this problem. and helps you to finish your problem off.